All right, so far we've been measuring stuff on flat surfaces, but as we know quite well, the Earth is not flat. This is a photo from a couple of our students some years ago on a field trip to the Grand Canyon. But if we measured this hike on a map, if we just used a straight line distance, that would be misleading. The elevation changes here make this a much longer hike than if it was simply on a flat map. So how do we figure out this actual distance? Well, we need the map distance, that straight line distance that we're measuring on the flat map, but then we also need to know the elevation change. So the map distance we often refer to as the run, the elevation change we refer to as the rise, and you may already be referencing some work that you've done in the past with rise over run in order to figure out slope angle, but what we're concerned with is the distance that we're actually hiking, right? So what we're going to do is go visit our old friend Pythagoras, who came up with this lovely little theorem, a squared plus b squared equals c squared, and it uses this principle. So in this circumstance, the map distance is a, the elevation change is b, and then c is the distance that we're looking for. So how the heck do we find b? Right? We know how to find a. We use the scale bar, we measure on the map, and we go from there. But how do we figure out b? Well, hopefully we've got a topographic map of the area. And the topographic map, in addition to a few other things that we're going to talk about in the next video on contours, gives us elevations at certain areas. So this is basically representing the surface of the Earth with a series of lines. And these contour lines help us understand the shape of the natural features, and then it also has man-made features on it as well. There's some little tiny dots down here. You might be able to see that are buildings. When you look at the map, when you did the scale quiz, you saw lots of little buildings on there as well. And in the, well, I actually don't think I gave you map examples. In the cheesy little topographic music video that I gave you, it references the colors of things. So pink is urban areas, green is vegetation, etc. But I don't think it actually shows you the map. But anyway, so the contour lines are the things that we're interested in this case, and then also things like benchmarks and spot elevations. So benchmarks and spot elevations are places that have been surveyed, and their distance relative to mean sea level has been calculated. So remember, mean sea level is not exactly the same all the way around the Earth, right? It fluctuates a little bit, but it gives us a basis for measuring elevation, right? So in this particular case, we have a couple of benchmarks here, and they're always marked with this benchmark and then the elevation and then a little X to show you where the surveyed point actually was. So this one is 241 and this one is 240. And then you would consult with the fine print on the map to figure out the units. This is most likely feet because it's a US topo map, but you'd always want to make sure of that. And then these measurements here, this little X just says 241, this one says 242, there's another one here that says 241. Those are spot elevations, and so those don't have the fixed plate in the ground that get used, but those areas were surveyed, presumably for the development of the airport here, and then marked on the map. But we have all of those things, and so from that we can then calculate the difference, right? So let's say that I'm gonna hike up this road here, and I can measure this distance between these 2 points, between these two benchmarks, on the map, and it's 500 feet, right? So my distance A, the map distance, is 500 feet, which I've already measured using the scale bar. And then I want to figure out my vertical distance. So this benchmark is 3,263 feet. This one is 3,227 feet. So I just need to find the difference between the two. So 3,263 minus 3,227, that's going to give me my elevation change. We plug that in here, right? A squared plus b squared equals c squared. So a squared, we take 500 and we square it. B squared, the difference between these two numbers is 36, so 36 squared equals c squared. So then I'm going to run these through a calculator, and I'll get 251,296, right? And remember, we do the squares first before we do the addition. And that gives me c squared, and then I'm just going to take the square root of both sides of that, and I'm going to get just a little bit over 500. So 501.3 is my actual distance hiked. So obviously this is not a super dramatic slope. It's only a 36-foot change over the course of this 500 feet. But I am walking slightly more than 500 feet. So if this was a much more dramatic elevation change, like for example walking from the bottom of campus to the top of campus here at HSU, we would see this number be much different than the straight line distance. Okay? So that's how we get the vertical distance incorporated. That's how we measure slope, and that's going to be a part of your lab for this week. There's 2 labs this week, the scale and the contour. So in the next video, I'm going to talk about the contour lines, how those are created. Okay, so back this one up and go through as many times as you need to get this process familiar, because this will be part of your scale lab, and then check in for the next one in a little bit.